Hello everyone, in this video we are going to discuss about Chemical Engineering GATE 2021 Fluid Mechanics questions with solution. GATE 2021 question paper and answer key link is available in my description box, you can download it. Question number 27. Consider a fluid confined between two horizontal parallel plates and subjected to shear flow. In the first experiment, the plates are separated by a distance of 1 mm. So this is dy. So the mm is converted into meter into 10 to the power minus 3 meter. It is found that a shear stress of 2 Newton per meter square. So shear stress is denoted as tau. Okay, has to be applied to keep the top plate moving with a velocity of 2 meter per second. So the upper plate velocity, that is u, 2 meter per second, while the other plate is fixed. So this is the stationary plate. In the second experiment, the plates are separated by a distance of 0.25 mm. 0.25 mm is equal to 0.25 into 10 to the power of minus 3 meter. Okay, so this is denoted as dy. It is found that a shear stress of 3 Newton per meter square. Shear stress is denoted as tau. Tau is equal to 3 Newton per meter square. Has to be applied to keep the top plate moving with a velocity of 1 meter per second. In this experiment, top plate moving velocity 1 meter per second, while the other plate is fixed. So other plate is a stationary plate. In the range of shear rates studied, the rheological character of the fluid is. So we have 4 options. Answer for this problem is option B. I am going to explain how is it. Data, experiment number 1. So consider a fluid confined between two horizontal parallel plates and is subjected to shear flow. First experiment, the plates are separated by a distance of 1 mm. So here this is the distance, is right. So distance, this is dy. dy is equal to 1 mm. So this is 1 mm into converted into meter. So here 1 into 10 to the power of minus 3 meter. So top plate. So the top plate moving with a velocity u is equal to 2 meter per second. Shear stress tau 2 Newton per meter square. So other plates is fixed or stationary. So velocity equal to 0. So similarly the second experiment. So in this experiment, the plates are separated by a distance of 0.25 mm. So this is the dy, is right. So 0.25 mm is equal to 0.25 into 10 to the power minus 3 meter. So here shear stress value 3 Newton per meter square. Upper plate moving with a velocity of 1 meter per second, we should take small u. So here other plate is fixed. This is the stationary plate. We should take velocity equal to 0. There is no movement, is right. So objective of this problem, rheological character of the fluid. So whether the fluid is pseudoplastic or Newtonian or dilatant or ideal and inviscid flow. So we are going to check. So after calculating the value only we come to know. So answer for this problem, pseudoplastic. How is it? Okay. So solution part, this is the equation, shear stress and viscosity. This is a rheological behavior. So tau is equal to mu into du by dy whole power n. So here tau value is 2 mu into du by dy in the first experiment. So power n, this is the equation number 1. So the second experiment, tau value is 3 mu into 1 by 0.25 power n. This is the second experiment. So divide these two equations 1 by 2. So here first equation divided by second equation. There were 2 by 3 in LHS side, RHS side mu into 2 by 1 whole power n divided by mu into 1 by 0.25 power n. Which one is a common factor here? Mu is a common factor, so they cancel the term. Viscosity here. So rest of the part in LHS side 2 by 3 goes to 0.66. Am I correct? So then RHS side 2 by 4 power n. Okay. So we want n value. So after that we have to choose the correct value. So the rheological behavior. So what do you do here? Take ln both side. Ln of 0.66 equal to ln of 0.5 power n. Okay. So 2 by 4. This is 1 by 2 is right. 1 by 2 is equal to 0.5. So ln of 0.5 power n. So here apply the formula ln of a power x. So what is the mathematical formula here? X ln a. Apply this formula. So here RHS side x ln a. So here we have ln of 0.5 power n. So here x ln a. So what is this value here? N ln of 0.5. So what is the value of ln of 0.66 here? Then n into ln of 0.5. So from this find out the n value. So n is equal to ln of 0.66 divided by ln of 0.5. Rearrange this expression. Find out the n value. So here n value is 0.594. N is less than 1. So we know n is greater than 1, n is less than 1, n is equal to 1. Our answer is n is less than 1. So the n values are 0.594. Okay. So n is equal to 1. The fluid is a Newtonian behavior. N is less than 1. Pseudoplastic. N is greater than 1. That is a dilatant. Okay. But our answer is n is less than 1. So here answer for this problem is option B. Okay. That is pseudoplastic. This is n is less than 1. So where dilatant n values are greater than 1. So what is the Newtonian behavior? N values are equal to 1. What about the viscosity in ideal and inviscid flow? So here viscosity equal to 0 is right. So here our answer is n is less than 1. This is the correct option for this problem. Okay. So for further related videos you can like, share and subscribe my channel. Thank you very much.